In this video, I'll be going over operations on whole numbers. Remember that whole numbers are the numbers starting from 0, going all the way to positive infinity, meaning 0 and all the positive counting numbers. Now, when we talk about operations on whole numbers, we have to take into account what we learned earlier about place value. Remember that place value just refers to the value that each digit in a whole number has. Now, say for instance, we're going to work with addition, and let's also say subtraction for now. I will give two arbitrary numbers. So let's start with 2,543. And let's say I'm adding that to 72. I need to find out the result of this number. I need to find out the sum of 2,543 and 72. Now, I can't just write this out in any random way when I'm adding. And I would urge you all to do the same. I want you to align it vertically, and I want you to pay close attention to the place values of the digits. I like to write down the larger number on top. That just makes it much easier for me. It doesn't really have to be that way as long as you're aligning by place value, but I think it's easier visually to see it this way. So larger number on top. I'm going to add the smaller number, but I'm not just going to put it anywhere. I'm going to align the place values of the digits. 3 is in the ones place and 2 is in the ones place, so I know my 2 is going to come directly under my 3. And 7 is in the tens place, 4 is in the tens place, so I know my 7 will come directly under the 4. Now I know I've aligned it correctly. Sometimes some students, they will write it as 2,543 plus 72 like this. This is completely wrong. This does not take into account the place value. Always look at the place values of your digits and align it accordingly. Now, let's just solve normally. 3 plus 2 is 5. 4 plus 7 is 11. So 1, carry 1. 1 plus 5 is 6. And then 2 just comes down. And remember, we talked about the commas every 3 digits. So 1, 2, 3. That's where my comma will be. Now, we've gotten the result for our addition problem, but I want to talk about some key terms you might hear or see in math problems. Now, anytime we're adding any group of numbers, so it could be 2 numbers, 3 numbers, any number that we are adding, that number is called an addend. The numbers being added are called addends. So 2,543, that's an addend. 72, that's an addend. These are numbers that we are adding, so they're called addends. Now, if we have the results of addition problem, so we've added this, we got 2,615 as our result. This result of an addition problem is called a sum. You've probably heard this word before. If I were to tell you, give me the sum of 5 and 4, you would say, okay, sum means adding, so I need to add 4 and 5. 5 and 4, 4 and 5, that gives me 9. 4 plus 5 gives me 9, so that's my sum. These are key terms that you should keep in mind because as you work through your problems, you might see, hey, these are your addends, and you should be able to determine what you need to do with your addends, or find the sum of some number and some number, and you would need to know that sum refers to the result of an addition problem. Now, we're going to do the same thing with the subtraction, and I'm going to use the same numbers. So I have 2,543, and I'm going to subtract 72 from this. Same principle applies for subtraction, meaning you are going to align based on your place values. So I have 2,543 minus 72. And I knew to place my 72 here because I'm lining up ones place and tens place. And of course, larger number goes on top because we're removing the smaller number. We're subtracting the smaller number from your larger number. 3 minus 2, 1. 4 minus 7, we know that has to turn into a 14. So we get 7. Because we borrowed 1 from the 5, that's a 4. So 4 and then 2. 2,471, and I place my comma after every 3 digits, moving from right to left. So 2,471. Now, in a similar way to the addition problem, we have some key terms here. The key terms aren't as popular for the numbers that we are subtracting from or or the number being subtracted, but I still want you to know them. The number that we are subtracting from, meaning the larger number or the number we are taking away from, is called a minuend. A minuend. And the number that we are subtracting, usually the smaller number, is called a subtrahend. And that should actually have an A right here, subtrahend. Our result is called a difference. And you've probably heard the word difference before. Like, what's the difference between 8 and 3? So you should know, okay, that means I need to subtract 8 minus 3 is 5. Or what's the difference of 10 and 5? 10 minus 5 is 5. This is probably more common for you to know, difference. You will not really see the words minuend and subtrahend being used. But you will see the words addends being used, and you will see the word sum being used as well. So these are key terms that you need to know. Now, for a subtraction problem, I also ask that you all check your work. And the way we can check our work for a subtraction problem is by doing the inverse operation. One thing you need to know about addition and subtraction, they are inverse operations, meaning they're opposites, meaning they can undo each other. If you have 5 plus 4 equals 9, 9 minus 4 would give you 5, or 9 minus 5 would also give you 4. They're opposites. They work like this. So in the same way, when I need to check a subtraction problem, meaning I need to check, is my work correct for this problem? I'm going to take my difference. So I'm going to take 2,471, and I'm going to add it to the smaller number, which is a subtrahend, and see if I get the minuend, meaning see if I get the larger number. So let's see. We have a difference of 2,471. I'm adding it to the smaller number, 72, and I'm seeing if I can get the larger number, which is, in this case, the minuend, 2,543. So if I did it right, I should get 2,543. 1 plus 2 is 3. 7 plus 7, 14. Carry the 1. 5, 2. And it seems like I did my work correctly. That's what would constitute a good way to solve subtraction problems. Not only are you doing the subtraction, but you're using the inverse operation of addition to check your work. Now, there are other operations that we can do on whole numbers. Obviously, by now you are familiar with multiplication. And the same rules will apply for multiplication as well. Let's say in this case, we are multiplying the same numbers, 2,543 times 72. By now, you know the typical drill. We're going to align everything by place value. So we have 2,543, and then we have 72, and we're aligning ones place, tens place. Now, we're going to just multiply regularly. We start with the number in the ones place for our smaller number. I like writing it, once again, bigger number on top, smaller number on bottom. 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. Carry the 1. 2 times 2 is 4. Plus 1, 5. I like putting an X here. Some people like putting a 0. I'm going to just go with 0 to make it less confusing. Now we move on to the next digit in our second number. 3 times 7 is 21. Carry that 2. 4 times 7 is 28. Plus 2 is 30. Carry that 3. 5 times 7 is 35 plus a 3. That's an 8, 38. And I'm carrying that 3 over there. 2 times 7 is 14. Plus that 3 should give me 17. And when I add this all up, 6, 9, 0, 13, carry the 1, 8, and 1. Now, again, commas placed every 3 digits, 1, 2, 3. So we have our comma. We have 183,096. All right. Now, similar to what I mentioned over here about some key terms, the numbers that we are multiplying. So remember, you can always multiply more than 2 numbers. It's 2 factors. I gave it away. Factors are the numbers that you're multiplying. You could have 2 factors, you could have 3 factors, 4 factors, but any number that you're multiplying, it's called a factor. And the result you get of multiplying your factors is called a product. If I were to tell you, find the product of 3 and 4, you should be able to say, okay, product, that means I need to multiply 3 and 4. 3 times 4 is 12. That's my product. So we've learned addends. Addends result in a sum. This is for addition. We've learned about minuend and subtrahend, which result in a difference. This is subtraction. And then we learned about factors, which result in a product. All of these 3 operations are typically done in the same way, meaning we align our numbers based on place value, and then we complete the operation. Now, we have one more key operation to go over, which is division. Now, let's say I'm going to use a simpler problem in this case. Let's go ahead with, let's see, 696 divided by 3. Now, when you have a division problem, you probably have a couple ways to write this. Obviously, I have one way written here with this division symbol where I have a bar and I have one dot over it, one dot below it. You might also see it sometimes be written like this. Or more commonly, when you're doing long division, which we will do in this case, you will see this little symbol that I like to call a cliff, but this little bracket of some sort where you have your numbers written like so. Let's talk about it. So I'm going to go with the long division method of writing it with the cliff, and we're going to just go through it regularly. So we check. How many times can 3 go into 6? Digit by digit, right? So 3 goes into 6 2 times. So 3 times 2, 6. I subtract. Then I bring down my next digit of 9. How many times does 3 go into 9? 3 times. So I write that directly over my 9. 3 times 3 is 9. I need to write down my 9, subtract, and then I bring down my other digit of 6. Same thing. How many times does 3 go into 6? 2. So I write that directly over my third digit of 6. 3 times 2 is 6. 6 minus 6 is 0. So I have no remainder in this case. I have a result of 232 after I divided 696 and 3. Now, just like these three operations, there are a few key terms that we need to know. When you have this symbol, which is a cliff, as I like to call it, the number inside, which is the number that you are dividing into groups, like over here, we have 696, we're dividing it into 3 groups. This number is called a dividend. A dividend. And I will also demonstrate how this would look with these 2 other ways of writing it. Dividend. The number that you are dividing, I guess you could say that it like the number of groups that you are dividing into, or the number of parts you're dividing into, or the number that you are, the number of groups you're dividing into. This would be called a divisor. So over here in this case, we're dividing 696 into 3 groups. The number of groups, the number of parts that we're dividing into is a divisor. So 3 is the divisor. Now the result, after doing all your steps, the result that we get on top of the cliff, that's our answer to a division problem, is called a quotient. This right here is called a quotient. So I might ask, hey, what's the quotient of 12 and 4? So you would be, of 12 divided by 4, so you'd be like, okay, then 12 divided by 4 is 3. 3 is my quotient. Now, sometimes when you are dividing, you reach a point where you are not getting a 0 even after doing all the steps. You might end up with something left over. Like you might have a 1 here, a 2 here, maybe a 5 here. That part that's left remaining, and that should be a key for you, is a remainder. And I'm just going to write it here, even though it doesn't really have a spot here. In reality, what you would do is you would write it next to your quotient. Like you would have your quotient, and then you would have an R for your remainder, and then you would write the amount that is remaining, meaning like 1, R1, R2. So remainder of 1, remainder of 2. So that's kind of what we have over here. These are the 4 main terms that you should know when dividing. Now, this is one way that we can represent division, but I showed you 2 other ways that you might encounter it in a math problem. So let's write those out as well. So we know the number that we are dividing into groups is called a dividend. So if you have this format, dividend divided by, and then the number of groups or parts you're dividing into, that's your divisor. So when you have it in this format, this is what this means. The number before the division symbol is the dividend, and the number after it is a divisor. And that should help you recognize how to rewrite it in this cliff format if need be. The other way you might see it is with this little bar over here. You can call it division bar, you can call it fraction bar. When we work with fractions, you'll get more familiar with it. But in that case, the dividend is a number on top of that bar. Dividend, and then the number on the bottom is the divisor. And of course, for all of these formats, whenever you get the result, that result will always be the quotient. If anything remains, that result, that part that's remaining, would be called the remainder. So those are the key terms that you would need to know for division, multiplication, addition, and subtraction. Now, you notice that for subtraction, we had a way of checking our work and determining how to ensure that our answer is right. We also have that in division. Because remember, like subtraction and addition are inverse operations, division and multiplication are inverse operations. So we can check our work by using the inverse operation of division, meaning using the opposite, which is multiplication. So over here, let's see. We will do that by multiplying our quotient, which is our result, by the divisor, meaning by the number of parts. And we can see if we will get that total number. So let's do it. 232 times 3. So I'm multiplying my divisor by my quotient by my divisor. So 2 times 3, 6. 3 times 3, 9. 2 times 3, 6. 696 matches my dividend of 696. So I know I did my work correctly. That's how I checked my work. This is a way I would expect complete work to be submitted for any of these operations when we're working with whole numbers. I'm just going to write over here at the side, inverse operations. Inverse just means opposite, and that's how you can work. These operations are the way you can use to check your work. So inverse operations, addition and subtraction, they're kind of like opposites for addition, for each other. So addition is the opposite for subtraction. And then multiplication and division are the opposites for each other. And you will see why inverse operations play such a key role later on when we work on some other problems with missing numbers. But right now, one way we know that it works is just for helping us check to see if we did our work right.